Welcome to the RS Expert Advice Podcast. In each episode, we interview a trusted expert in the electronics industry to provide purchasers, engineers, installers, and maintainers with valuable insights into the product and technology solutions that can help them overcome common challenges and add real value to their workflows. We hope you enjoy this episode and that you learn something useful and new. Today, I'm speaking with Rohit Itticheria, a product manager in the Industrial Control Division at Eaton, a leading global power management company committed to enabling safety, energy efficiency, and sustainability improvements about motor controls. Welcome, Rohit. Thank you for joining us today.
Thank you, Maxim.
So please introduce yourself and tell us a bit about your role at Eaton.
Absolutely. So my name is Rohit Itticheria. I am currently the product manager for IEC, XT contactors, and panel components in our Industrial Control Division at Eaton. I've been with Eaton 15 years, fresh out of school from a leadership rotational program for engineering at Eaton. Later, I completed roles in product engineering and then moved into operations type leadership roles for a while. Then I made another transition into product line marketing, where I am at right now.
Please also provide us with a brief introduction to Eaton.
So Eaton is an intelligent global power management company that is over 100 years old. Eaton was founded in 1911, and it serves customers in over 170 countries worldwide. Our vision is to improve the quality of life and the environment through the use of power management technologies and services. People have seen our brand promise, which is we make what matters work. So at Eaton, we truly believe that power is a fundamental part of just about everything people do, right? So technology, think of technology, transportation, energy, and infrastructure. These are things that the world relies on every day. So that's why Eaton is dedicated to helping our customers find new ways to manage electrical and mechanical power more efficiently, safely, and sustainably. If you think about Eaton, within Eaton main sectors, we've got the electrical sector and the industrial sector. Our industrial sector is comprised of our aerospace, vehicle, and e-mobility businesses. Our electrical sector is a leader in electrical products, systems, and services for power quality, distribution and control, and wiring. So I sit in the Industrial Control Division, which rolls up under the electrical sector.
And you joined us today to talk about motor controls. Can you please give us a brief overview of what these products are and what they do?
So motor controls or motor control devices, they are a pretty wide range of products used in the electrical industry to help control or protect motors and motor applications. So to help understand what motor controls are in general or what they do, it's important to know what are some of the high-level functions, right? So I would personally classify the functions of a motor control system into maybe 6 main types. The first function of a motor control system is starting. Think of starting a motor as one of the main purposes of a motor control circuit. The easiest way to simply start a motor is across the line starting. So what a customer would do is simply connect a motor directly to the power line. The second function I would categorize is of a motor control system is stopping, right? So stopping is simply stopping the motor. The best way to do that is simply disconnecting the motor from the power line and allow it to coast to a stop. There may be some conditions where that motor may be stopped more quickly, or that a brake may be needed to hold a load when that motor is stopped. A third function, a way to categorize what a motor control does, is a feature called jogging or inching. So jogging and inching are methods that customers use to move a motor with really short, precise jabs of power. So this is generally done to move a motor or a load into some desired position. The difference, if you think about it, between jogging and inching is that jogging is done by momentarily connecting that motor to a full line voltage, whereas inching can also be done, but the difference is you momentarily connect that motor to a reduced voltage. The fourth function, if you will, is speed control. So there will be applications where customers require variable speed. So one really nice way of doing variable speed control is using variable frequency drives. Now, you also have a really important function that is motor and circuit protection. So it's really important for the motor control to be able to protect both the circuit components, and typically that's done with fuses and circuit breakers. And The motor is protected typically with a set of components known as overload relays. And the last, but absolutely not the least, function of a motor control system is safety. It's a very important feature for any motor control designer to make sure that the operator or the persons that may be in the vicinity of that machine, they are protected. So it's important to have that safety feature as well. And motor control systems, in general, I would say they can be categorized into three main types, right? To further understand what a motor control system is, um, they can be classified as manual or motor control systems, semi-automatic, and automatic. So manual controls are, think of a system where an operator must go to the location of the control to initiate a change in the state of the control system. So these manual controllers are typically very simple devices that all they do is they just connect the motor directly to the line. Manual control can be done by simply by connecting a switch in series with a motor. Now, the second of the three is the semi-automatic control. So there, you will see customers utilizing a plethora of devices like push buttons, limit switches, pressure switches, and other sensing devices. What this does is it controls the operation of a magnetic contactor or a starter. And what that does, it allows now for that control panel to be situated a little further away from the motor or starter. To remember, the operator can still initiate certain actions such as starting and stopping, but he or she does not have to go to the actual location of the motor or starter. And the last type of a motor control system is the automatic control system. So there, you still have pilot and sensing devices that are employed in the system, but in this instance, the operator physically does not have to initiate action. So once a certain set of control conditions have been met, that system will autonomously continue to operate on its own. So think of this, right? A good example of an automatic control system is a system we're all familiar with. It's our heating and cooling systems in our houses, right? So when someone sets the thermostat to a desired temperature, that heating or cooling system will continue to operate now without further attention from the homeowner. So that circuit has sensing devices within it that will shut the system off if there's an unsafe condition like maybe motor overload, excessive current, no pilot light or ignition, and so on and so forth. So just in general, those are the three ways I would categorize motor control systems. And motor control systems in a real life application are used in so many different places from industrial standpoint. I've seen them used in various segments like material handling, water, wastewater, packaging, HVAC, food and beverage, processing plants, machine builders, panel builders, etc. So very, very widespread usage of the motor control system, but a very important system in today's day and age.
Thanks for the comprehensive overview. What are some of the key characteristics that customers need to consider when choosing motor controls?
So when choosing motor controls, there are definitely several factors a designer has to keep in mind. I would categorize the factors as maybe five main buckets, right? So a designer or a customer needs to understand, number one, what is the power source that's in play here? It's important to understand, is the machine requiring single phase power or three phase power? One needs to know what the horsepower of the motor or the motors are. What is the level of inrush current that is expected? Would the motor require some type of reduced voltage starter to limit the inrush current? The existing power supply, is it capable of handling the power requirement of the machine, or is it necessary to maybe upgrade and install a new power system? Another thing to keep in mind when it comes to power requirements, the availability of power can vary greatly from one area of the country to another area of the country, right? So there are heavily industrialized parts of our country where power companies will typically permit larger motors to be started across the line with higher loads than companies that supply power to areas that have light industrial needs. So it's important to understand the type of region that the system is being deployed from a power standpoint, power requirement standpoint. The second factor that a designer needs to keep in mind is the motor connections, right? So the designer has to understand various factors like the horsepower ratings, the service factor ratings, the temperature rise, the voltage, full load amp ratings. All of this information is typically found on the motor nameplate. Another factor to keep in mind when designing a motor control system is the type of motor starter that is required, or the motor that's required. So you could have essentially two major classifications. You have one that's NEMA and IEC. So NEMA is an acronym which is National Electrical Manufacturers Association, and IEC is International Electrotechnical Commission. So two separate organizations, two separate sets of standards. That is something that a designer or a customer needs to keep in mind. The fourth condition or factor that a customer needs to remember is very simply the environment. What is the end environment where that motor control system will operate in, right? So you need to know, would the control need to be housed in a general purpose enclosure? Is the end system subject to moisture or dust or shock and vibration? Does the motor controls need to be in a hazardous area that require explosion-proof enclosures? Some locations may even have like corrosive vapor or liquid and various extremes of temperature. So all of those conditions need to be considered when you select the right motors and the right control components. Last but not the least is codes and standards. So that is a really important feature to remember when you're selecting your motor control system, is what is the regulatory bodies or standards that are in play there. So a couple of examples that people need to keep in mind is OSHA, right? OSHA stands for Occupational Safety and Health Act. So it really is a regulation that requires requires an environment that needs to be free of any recognized hazards that can cause any serious injury. A second regulatory body or standard to keep in mind is UL. UL stands for Underwriters Lab. The context here is Underwriters Lab was established in the past by insurance companies in an effort to reduce the potential for fires that could be caused by electrical equipment. So a lot of our equipment is tested to UL standards. Another standard or regulatory body is NEC, which is the National Electric Code, which is part of NFPA or the National Fire Protection Association. So this body sets really the rules and specifications for installation of electrical equipment. And as I also mentioned previously, you've got NEMA, which is again very much an American standard, but it has its own sets of components that are designed around it. And then you have IEC, which is the International Electrotechnical Commission, which is more of a global standard. So all said and done, there are various features, various factors that go into the helping design a motor control system.
How are current industrial market trends like digitalization and energy efficiency affecting motor control designs?
That definitely is an impact that major industrialization trends like digitalization and energy efficiency, they are definitely impacting our motor control design. So there are a couple of ways that we are seeing this trend happen. One example is efficiency, right? So digital technologies such as variable frequency drives and smart motor systems, they are improving the efficiency of motor control systems. So what these technologies allow for is much more precise control of motor speed and torque. And what that does is it reduces the energy consumption and also the operational costs for the end customer. So win-win, right? The second example where I see an influence in is on smart applications. So the integration of digital solutions like sensors, big data analytics, and artificial intelligence, this is helping enable the development of that much more smarter motor control systems. So these systems can optimize the performance in real time by analyzing the data on operating conditions, product quality, and environmental factors, and thus empowering that end customer to be able to be a better steward of their system. The third way I'm seeing these influences happen is on maintenance, right? So digitalization is really facilitating predictive maintenance by now the data is being used from sensors and other monitoring tools to help predict when a motor might fail. So this helps in scheduling maintenance before a breakdown occurs, right? And thereby reducing the downtime and extending the lifespan of the motor. Energy savings, that's another example where the application of digital technologies to motor-driven systems, they are absolutely leading to significant energy savings. So a good example is the use of digital twins and artificial intelligence. This is enhancing energy management and improving system efficiency, potentially achieving energy efficiency improvements as high as 20 to 25%. And last but not the least, regulatory compliance, right? So as energy efficiency becomes much more of a critical regulatory requirement, digital motor control systems help industries comply with these regulations by providing that much more detailed energy usage data and thus helping enable that much more efficient energy management. So absolutely, these two trends are having an impact on the future of our motor control designs.
And what differentiates Eaton motor control products from competing solutions?
So Eaton Motor Control, I'm happy to say it offers best-in-class solutions to the market out there to our customers. So we've got various innovations in the design and development. This allows our customers and users to really, in a very simple way, reduce material costs, reduce installation effort, enhanced panel safety and performance, all in a very, compact and nice space-saving design.
Please introduce us to Eaton's XT line of motor control products.
So the XT line of IC control is in my mind, a complete and elegant product line. It consists of a number of components within it, like XT contactors, XT IC control relays, manual motor protectors, overload relays, accessories, starters, combination motor controllers, and so much more. XT line, it applies new technology and design to help our customers achieve really five basic needs: and improved production, lowered material costs, improved equipment performance, improved equipment usability, and much better equipment safety. So I covered really high level five main needs, but I'm going to dive a little bit into detail under each of those points to help really outline the advantages that our customers gain from it. So from a production standpoint, XT has what's known as toolless assembly. So an end customer is able to take a product, which is a very modular design, and build, how do you say, larger assemblies or combination style starters. And I will reach now and give an example of a combination style starter here. So this is an example of a combination style starter. What this is, the point I'm trying to outline here is how you've got different components that really match together with almost toolless assembly. So by being able to build a modular design, we're able to create larger and larger assemblies fairly quickly. Some other examples or benefits rather that we have is from a material cost saving standpoint is that Eaton offers the smallest 10 horsepower contactors in the market. We have what's known as side-by-side mounting to help with reduced panel size, a very low coil consumption with an efficient coil design, and a really nice built-in surge suppression in our electronic coils. I'm happy to say that Eaton XT IEC motor control line offers best-in-class warranty performance when compared with similar electrical manufacturers out in the market. We also have what's known as a slidable DIN rail adapter. So what that does is it allows for easy component replacement and allows for last-minute changes and design flexibility that a customer may run into. And very importantly, from a safety standpoint, we have a nice feature of what's known as the top button dual chamber design, and what that does is it allows for a more secure termination of wires of different sizes. So it definitely limits the potential for a loose wire, which is something we try to avoid in industrial environment. I did also want to take the opportunity to talk about a new product launch or a new design that has come out recently, which is known as Push-In. So Push-In technology is really is an upgrade, if you will, to the termination style of our contactors and motor controls. So typically, motor control has always been screw style termination or cage clamp. So now we have Push-In, and Push-In is simply a customer taking a conductor and inserting it into the top of a contactor. And I'll reach back to give you an example of one. So this is an example of a new and redesigned Push-In contactor. What this is now a customer can take a conductor and simply insert it to the top of the termination. And to remove it, one simply takes a screwdriver, inserts it in, and is able to pull it out. The benefits of having a Push-In device is really amazing, right? So one of the big benefits are faster time commissioning. The end customer is able to have at least 50% time savings from going from a screw style termination to simply inserting it in. Think of a shop foreman or a shop supervisor not needing to maintain a set of calibrated torque tools on the floor. That's a win-win. We have also seen that Push-In helps enable what we call future-proof wiring systems, or it helps enable automated building, because we're seeing a lot more customers and industries moving towards that automated assembly, and having Push-In is a nice step in that direction. A really nice key feature of the Push-In is the shock and vibration aspect of it. So when compared to screw, there is absolutely an improvement from a shock and vibration standpoint. And think of a customer or a panel builder who's building a panel in one part of the country, puts that giant panel on a flatbed truck and sends it down to the other part of the country. It's bouncing on the road, it gets to its end customer, and now that end customer has to dedicate a quality resource to go and check every single screw termination. Right now, with a push-in, all that time, all that labor is eliminated. So there's definitely some really awesome shock and vibration properties that can be utilized that allow for that labor force to be more efficiently used. So you will see push-in devices typically in a lot of the panel builders, machinery OEMs, electrical OEMs, and we are starting to see a lot more interest on our push-in devices.
And can you tell us a little bit more about Eaton's XT contactors?
So Eaton's XT IC contactors are powerful, efficient, and very versatile components that we combined with our full range of accessories. They are really small, compact designs that allow for our customers to benefit from savings on panel space and panel costs. A nice benefit of our XT contactors is that they come with DC coils with integrated surge suppression circuits, which then reduce the power consumption, making the design that much more energy efficient. And that also reduces the size of the power supply. Good to remember that XT contactors come with both reversing and non-reversing styles. The AC and DC contactors share the same frame size and offer up to IP20 protection. A nice feature that we have is that our contactors come with full UL, CE, and CSA marks and certifications, which make them a really nice, excellent candidate for any customers that want to use our devices in an IEC or a global application. So looking at our product portfolio, we have contactors, IEC contactors that start from 7 amps all the way to 2600 amps. And I'm going to reach back to show you an example of just the size differences of these devices. So this right here is one of our larger frame size devices. This is the 150 amp device. And this right here is a smaller 9 amp device, just to show you kind of the range and the breadth of our offering. Really is a wide range of offering from a frame size standpoint. Also, our XT IC contactors have a wide temperature range of minus 25 degrees C to plus 60 degrees C. We have uniform accessories for 3-pole and 4-pole contactors. And we have, like I mentioned before, those double box terminals that are really nice to allow for different wire sizes to be terminated and to be able to mitigate the potential for a loose wire. So all said and done, XT line of IC contactors is a really powerful, elegant solution. It offers a really nice set of starting and protection offering of solutions which are ideal for our control panels. And you'll see a lot of our XT contactors used in segments like material handling, HVAC, food and beverage, water, wastewater, and other segments as well.
Please tell us a bit more about Eaton's XT IEC control relays.
So Eaton's line of XT IC control relays, it really consists of mini and standard frame control relays and auxiliary contacts. This can be electronic on delay and multifunction timers and electronic star delta timers for use in star delta combinations. Another type of relays that we offer are what is known as overload relays, which is offered both in the thermal as well as electronic relays. Really, the function of an overload relay is to monitor for a high temperature condition in the motor pump, and then it uses a normally closed auxiliary contact to switch off the main contactor. I'm going to reach to the back here and show some samples here. So this right here is an example of overload relays. And like I mentioned, we have got two styles. This right here is the bimetallic overload relay, and this right here is the electronic overload relay. Both are excellent functions that do essentially the overload function in a different setting, if you will. The differences between the two are quite nuanced in a way. The bimetallic overload relay, it's more of a traditional offering. These heaters have a fixed tripped class, and really the function is that when the current flows through this heating element, the bimetallic strip that's inside starts to expand and bend, and that causes a trip to slide. And once that trip slides a certain distance, it starts to trip. On the other hand, you've got the electronic overload relays, which instead of using a mechanical bimetallic strip, it uses current transformers and electronic circuitry inside, And what this does is that when the current flows through the device, it creates a magnetic field and produces a smaller current through the CT wires. So this connected to the circuit board is where the signal is processed. So the other really nice benefit of these XTOEs, or electronic overload relays, is that we have the ability to add communication modules to the bottom of these electronic overload relays. And now we have made the XT line that much more powerful from a communication capability standpoint. So various kinds of relays that we have within our XT IEC portfolio.
Can you tell us a bit more about Eaton's XT IEC motor protectors as well?
Sure. So Eaton's family of manual motor protectors, or as we call it, MMPs, they feature a push button or a rotary on-off manual disconnect, a Class 10 adjustable bimetallic overload relay, and a fixed magnetic short circuit trip capability, all inside one compact unit. These manual motor controls offer ideal space savings and cost savings, such as the manual starters, manual motor disconnects, and self-protected manual combination starters. I'll pause to show an example of a manual combination starter. So you have seen this example before. So this was the manual self-protected manual combination starter. What this consists of is an XT accessory known as the line side adapter. We have the manual motor protector here, and you have an XT contactor, all in one nice compact design. We are talking here about the manual motor protectors, and that is this device right here. So this device, going a little bit into the details, so this has right here an on-off rotary handle with a lockout provision. It has a visible trip indication, Class 10 overload protection, phase loss sensitivity, fixed short circuit trip, motor applications from 0.1 to 63 amps. It's DIN rail mountable on the back, and it has built-in heater and magnetic trip elements to be able to protect the motor. What's interesting to note here is that this right here is an XTPR, or a rotary style manual disconnect. We also have in our portfolio what's known as an XTPE, or an electronic MMP. Now, an electronic MMP has that much more enhanced precision, and it has the capability to have SmartWire or Modbus RTU connection capability. So now you added additional communication connectivity to our XT IEC portfolio.
Is there anything else you'd like our listeners to know about Eaton, its motor control products, or its push-in terminal technology?
Just in general, Eaton's a fantastic company. I'll say I've been very lucky to work for a company like Eaton, and I sincerely mean it. Like, I truly believe at Eaton, we believe that power is a very fundamental part of just about everything we do. Technology, transportation, energy, and infrastructure. These are things that we all rely on every day. So I'm really happy to work for a company that is dedicated to helping our customers find new ways to help manage their electrical and mechanical power efficiently, safely, and sustainably. I'm happy to say that we offer best-in-class motor control products. I personally am always available, as the rest of my colleagues at Eaton, to talk further with your audience, your customers and engineers on our motor control offering, our XT-IEC push-in devices, and any other applications you may have. We want to help solve your problems and make life easier for all of us. So once again, thank you for giving me this opportunity to be part of this podcast.
And thank you, Rohit, for taking the time to speak with us today. And thank you to our listeners for joining us for this episode of the RS Expert Advice Podcast. For more information about Eaton, please visit www.eaton.com/US. And for our complete collection of expert advice content, including more episodes of the RS Expert Advice Podcast, please visit us.rs-online.com/expert.